The unthinkable just happened. Scientists have finally captured and released the first real images of a black hole. After years of anticipation and countless scientific efforts, the most enigmatic cosmic entity known for its unfathomable gravitational force has finally been revealed. Behold the first ever real image of the notorious black hole. How were scientists able to capture the image of a black hole? What details of the cosmic entity were in this image? Join us as we explore how scientists finally announced the first real images of a black hole and more. Centuries ago, the notion of black holes was not an easy concept for scientists to grasp. The initial idea was proposed by John Michell, an English natural philosopher, who boldly predicted that there might be invisible objects in space, with strong gravitational fields that could be detected by studying the orbit of a star. However, it took several years for his prediction to be accepted by the scientific community. It wasn't until Albert Einstein's general theory of relativity provided a framework for modern gravitational understanding and spacetime structure. Einstein's theory suggested that massive objects could bend the fabric of spacetime, causing it to distort around them. This groundbreaking concept challenged Newton's view of gravity as merely an attractive force between objects. Einstein's theory had far-reaching implications, including the possibility of black holes. Black holes are believed to form when massive stars run out of fuel and their cores collapse under the weight of their gravity, creating a black hole where the star once stood. Despite Einstein's prediction, black holes remained a theoretical concept for many years, with some scientists remaining skeptical of their existence. Astronauts and scientists never give up on attempting to turn theoretical concepts into something they can see and maybe touch. Though they may not be able to physically touch what they explore, they strive to observe and understand as much as possible. In a groundbreaking discovery, astronomers Louise Webster, Paul Merton, and Thomas Bolton observed an imperceptible object. This object, Cygnus X1, orbited a blue star located 6,000 light-years away and represented the first ever identified black hole. Situated in the Cygnus constellation, Cygnus X1 consists of a massive blue supergiant star and a compact object believed to be a black hole. Astronomers further discovered that the system emitted highly energetic X-rays that are typically associated with violent cosmic events. However, optical telescopes couldn't see where the X-rays were coming from. Instead, they emanated from a nearby invisible object. Scientists hypothesized that the black hole could consume matter from the blue star's outer layer. When matter falls towards the black hole, it becomes extremely hot and emits X-rays that telescopes can detect. This led scientists to focus on studying the X-rays emitted by the black hole rather than the star itself. So, you've probably heard of the event horizon. It's the point of no return when it comes to black holes. Once something passes that point, it's almost impossible to escape the black hole's gravitational pull. It's like a cosmic trap that you can't get out of. Inside a black hole, the laws of physics we know and understand don't apply. Everything gets compressed into a tiny, infinitesimal point called the singularity, the heart of the black hole, where most of its mass is concentrated. The singularity's gravitational pull is so strong that even light can't escape it. That's why black holes are called black like cosmic vacuums that suck everything in, including light. That's one of the incredible characteristics of black holes, making them even more fascinating for scientists to study: the radiation they emit and the dust and gas surrounding them. It's like trying to study a blurry photo of a distant object. You can only get so close before you get sucked into oblivion. Here's where it gets even more interesting. Some scientists have been asking, what lies beyond the event horizon? Is there a portal there, a gateway to another universe, galaxy, or dimension? Some theories suggest that the singularity might be a wormhole to another galaxy. Can you imagine the possibilities? We could travel to distant stars and explore new worlds, all thanks to the glitch in the matrix that is a black hole. But not everyone thinks this is possible. Some scientists believe that black holes are simply holograms. Enrico Rinaldi, a scientist based in Tokyo, thinks that to truly understand a black hole, we must treat it like a hologram. The doggedness of American astronomers, Bruce Ballack and Robert Brown, led to another groundbreaking discovery. They pointed radio telescopes in Green Bank, West Virginia, at the center of the Milky Way and discovered a dim speck they suspected was our galaxy's central black hole. They were looking at a slice of the sky known as Sagittarius asterisk. This region was not alone. It came with a complex mix of radio, infrared, X-ray, and gamma-ray emissions. That was until the Event Horizon Telescope, EHT, project was set up in 2006, aiming to capture the black hole. It was all smiles in 2019, when the image of the black hole was clearly captured. The EHT released the first ever image of the black hole at the center of the supergiant elliptical galaxy M87, located in the constellation Virgo. It revealed a bright, ring-like structure with a dark central region, the black hole shadow. But what's happening inside the black hole? Well, we still don't know everything. However, using X-ray detecting telescopes such as NASA's Chandra X-ray Observatory, scientists can image the material spiraling into a black hole, revealing its location. NASA's Hubble Space Telescope can measure the speed of gas and stars orbiting a point in space that may be a black hole. Scientists use these speed measurements to determine the mass of the black hole. Hubble and Chandra can also image the effects of gravitational lensing, the bending of light caused by the gravitational pull of black holes or other high-mass objects, such as galaxies. Apart from satisfying our scientific curiosity, understanding the physics of black hole formation and growth, as well as their surrounding environments, gives us a window into the evolution of galaxies. Though Sagittarius asterisk is more than 26,000 light-years, 152 quadrillion miles, away from Earth, it is our closest supermassive black hole. Its formation and physical processes influence our galaxy as galactic matter continually crosses the event horizon, increasing the black hole's mass. Studying black holes also helps us further understand how space and time interact. As one gets closer to a black hole, the flow of time slows down compared with time far from it. In fact, according to Einstein's theory of general relativity, the flow of time slows near any massive object, but it takes an incredibly massive object, such as a black hole, to make a noticeable difference. There's still much to learn about what happens to time and space inside a black hole. The more we study them, the more we can learn. The Event Horizon Telescope project creates images of black holes using a global network of radio observatories in unison, effectively creating an Earth-sized telescope. This is how the first ever image of a black hole was captured. The brightness and pattern of the gas around SGRA asterisk were changing rapidly as the EHT collaboration was observing it, but like trying to take a clear picture of a puppy quickly chasing its tail, said EHT scientist Chiquan C. Kani. Medeiros added, "Everything we have observed so far is in line with what Albert Einstein predicted. The same holds true for the black hole at the center of the Milky Way galaxy, which was also studied by this research consortium." Medeiros is optimistic that with advancements in computer software and telescope hardware, the image of the M87 black hole will continue to improve and become more accurate. She believes the image we see today may look entirely different in 20 years. With technology advancing rapidly, the image of the black hole might become even more detailed and precise. providing us with a clearer understanding of these mysterious cosmic entities. Let's embrace these new feats our scientists have achieved and give them their flowers until an even better, closer picture of a black hole is captured. Do you think that clearer images of black holes will be captured soon?